For the differential equation dy dx equals xy, y equals -2 when x equals 1, estimate the value of y when x equals 3 using h is equal to 1. So like last time, let's set up a table. X, y, dy dx, h, and delta y. Note this h, very large value. So we're starting off, x is 1, y is -2. dy dx is x times y. So that is going to be 1 times -2 is -2. H is 1, giving us delta y is -2. So moving across to the next x, remembering the step length is 1, the next x would be 2. And then the y will be the current y, add the delta y, so -2 add -2 is -4. So the next dy dx, multiply x and y is -8. H is 1, this is -8. The next x is going to be 3, and then -4 add -8 is -12. Now we don't know how to solve this differential equation yet, but when you do, why don't you try it to find the exact value? And you'll find, because of this large step length and the fact that the gradients of this get very, very steep, that this -12 is a long, long way out. And we could investigate this a little bit at this stage on our calculator. So what we could do here is, let's just delete the table and go back here, and let's go up to here, and let's use maybe a step length of 0.02. I've chosen that for a reason, you'll see why. And then we need to execute there and go down into our next equation. So remember, we need to make that into 0.02 as well, because that's the step length. But this time, the gradient was an times bn, because that is the, let's just check that. Yeah, that looks okay, because it's xy. Okay, let's have a quick look at the set, because I think the 0 to 100 is okay. Our a0, though, is 1. That's the initial value of x. And our initial value of y is -2. And I think that should then be okay. So we can exit from there. And let's generate our table. Now, once again, we're going to need to flick right the way down to the end of the table. There must be a quicker way of doing this that I haven't figured out yet. We're going to go all the way down. So we can see here we've stepped to 2, and I've got -8.676, where when x is 2 here, we've only got -4. So it's already a long way out because of this steep gradient and the huge step length. And let's keep going. And if you look at those bn plus 1 values as we go down this table, how quickly they're getting large and negative. And so when we get down to here, it's at -98.47. And I can tell you even that's out. From memory, I seem to think when you solve the differential equation, you get something like -112. So it is really a long way out because of that large step length.